power output of a generator is measured in megawatts. One generator is producing 100 megawatts, which is 100 million watts. That's enough to power 1,000,000 100-watt light bulbs. The generators are directly linked by wires to transformers outside the building. The wires from the generators are fed through these silver tubes into the transformer. The voltage is stepped up from 16,500 volts AC to 230,000 volts AC. This is done to reduce the loss of energy during transmission along the lines.
Well, the power travels through these high voltage lines to the towers. Now, the reason the towers are at angles is so the wires don't touch the canyon wall. Now, tracing those wires, you can see they travel to Los Angeles, Phoenix, and Las Vegas.
The wires are divided into different directions at a distribution center. At this point, the wires are carried by great pylons perched along the horizon to the surrounding towns. The electric current from these power stations also flows down the overhead cables heading for Las Vegas. The high-voltage electricity arrives in Las Vegas without too much power loss. But 230,000 volts is extremely dangerous to use in homes and hotels. So it goes to a substation, where it's stepped down by various transformers, from 230,000 volts to 12,500 volts. It's then sent to nearby hotels. A little bit of ancient Egypt comes to town. This fun-packed pyramid is one of the biggest hotels in the world, with over 4,000 rooms. Its demand for electricity is like that of a small town. The Luxor offers a pharaoh's welcome to over 8,000 guests, creating a huge demand for electricity.
Okay, we get our power from Nevada Power Company. We have two feeds into the hotel. It comes in at 12,500 volts, in cable like this one here. It comes into two main switches. From these switches, it goes on into a line of switches inside of this room here. And from there, it's distributed to various transformers and all around the hotel here.
The Luxor Hotel needs its own bank of transformers to step the high voltage alternating current down to various voltages.
Okay, you're seeing three big coils in there. That reduces the 12,400 volts down to 4,160 volts. This is the power that we use for our air conditioning units. And then it goes to another bank of transformers that breaks it down to 120 208 volts that we use for lighting and for slot machines, gaming, and whatever else it might be.
But for the folks who don't have a home with 4,000 rooms, they don't need so many transformers. One is usually enough to get yourself hitched to electricity. This transformer steps the voltage from the substation right down to 110 volts AC. These transformers are dotted all over Vegas, from the famous Vegas Strip to the suburbs. If it wasn't for this routine of stepping up and stepping down, most of the electricity would be lost before it got to Vegas. Electricity is generated at 16,500 volts AC, stepped up to 230,000 volts AC by a transformer and sent long distances down the power lines. Then it's eventually stepped down to 110 volts AC before it gets into homes. But why bother to step the voltage up and then down? 230,000 volts is extremely dangerous. Stepping it down to 110 volts AC is much safer. But why step it up in the first place? Why not just generate and transmit the alternating current at a much lower voltage? If they did that, there'd be a big problem. To transmit electricity at low voltage, the current has to be high to compensate for the low voltage. And high current heats up the wires. This is an infrared image of the wires at low voltage AC. They appear white because they're hot. With high voltage and therefore low current, the wires barely show up because they're not so hot. Heat wastes energy, so if we transmitted at low voltage and high current, we would end up with less electricity reaching our home.